Hello, you guys. I just wanted to send a video of my own. I will probably be using my own videos from now on, but I wanted to send one about this stuff right here in this concept. Whether you have already showed me your homework or not, that's fine. You will see the correct answers tomorrow, and I can give you some feedback and answer your questions tomorrow when you see the correct answers. But I want to explain one of these harder problems, like question 3. And this is question 3 on your homework. And for the most part, those of you that are sending in your work have it correct. You may be off by just a number or so, but we will narrow down those asymptotes the more that you see them. But for number 3, let's do this one together. So we are going to take a look at this function. This function has 3 things. And so we are going to do each function at a time from left to right. So we're going to do the domain of this function right here. Then we're going to do the domain in the middle, and then we're going to do the domain on the right. By doing it in that order, we should be able to get the correct order of these domains. Some of you are sending me these domains, but they're not in the correct order. And once we do that, I will show you what I'm talking about. So domain remembers all your x values. So we're talking about all our values that are along the x-axis. And so I look all the way to the left of this graph. This graph started all the way over here. You can assume that this line is going forever. You can assume it's going forever that way. And the number that's forever that way is, in fact, negative infinity. Oops. Sorry, that's going to happen a lot. I need to get a stylus for this thing. But it's going to be negative infinity. Alrighty. And then we are going to go negative infinity, and then I'm going to all of these x values. Everything is fine and dandy while I'm going over here. And then once I hit somewhere right here, this graph has an asymptote. And remember, asymptotes are like a brick wall. You can't ever really you can't get past this wall. So I need to figure out where this is, because my graph does in fact stop here. This function does stop along this x value. I know you're thinking it goes up to infinity, but we want to do x value. So what x value does this stop at? And I'm going to erase this now. The x value that this stops at is right here. And this x value is x equals negative 3. So my domain is from negative infinity until I hit here, which is negative 3. Ooh, negative 3. Okay, then I want to figure out this function. So I'm going to go in order. This function stops. Remember, we don't want any jumps. So where my domain ends, it needs to pick back up there. Sorry, this is so sloppy. I'm literally just using my finger, so sorry. And so I need to pick it back up at negative 3. And that should make sense. I'm going to erase these marks that I've made. But that should make sense because I'm looking at what x value this function starts at. So it starts right here. It never quite hits here. It's like that brick wall. And that happens right here at x equals negative 3. And it goes across until what x value that this ends at is whatever x value is right here. We've got another brick wall right here. And so that happens at x equals positive 3. Alrighty. And then I have taken care of this function. And I'm going to erase this mark right here. Oops, that's not the eraser. And then I am going to think about what's going on in this function right here. So this function right here, the x value that it starts with from left to right is whatever x value is over here, because I've got a brick wall that this is starting at. From left to right, it automatically starts at this brick wall. And that brick wall happens at x equals 3. And that should make sense because we don't want any gaps. So remember, where this function ends, we want this one to start. And so that's going to go from 3, and then I'm going to follow all the x values. It goes forever, 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 and that is to infinity. And so that is the correct domain. And so we want to do that in order, because doing it in order means that there is no jumps. So I've got negative infinity to 3. Then I go from negative 3, I stop, and then I start again at negative 3. Then this middle function ends at positive 3, and then I start again at positive 3. And then the range is a little bit easier in terms of there's less work, but there's more to think about. So I'm going to erase some of this stuff that'll cut into the range, but you should have been following along from this point on into the video. So me erasing this won't be that bad. But the range, it remembers all your Y values going from how far low and how far high my graph goes. So we're going to think about all the X and Y values that this graph comes across. So this graph goes all the way down. So remember, the lowest spot that any one of these three functions, right now we're thinking about any of these three functions. What points do all of these functions hit? So this function right here, we're going to look, it goes forever down. So the range is from negative infinity to, and then I see that this graph is only going as high as here. And then I need to ask myself, it's not continuously going to positive infinity. So it has to stop. And this graph stops right here. The Y value that it stops at is that Y value, which is Y equals 1. This Y value is Y equals 1. And so then it starts again where these functions, now we got to look at these functions. These functions start again where this, we're now talking, remember, we're talking Y-axis. So we're talking from vertically. This function starts again where the 1 is. Remember, we don't want any jumps. So it's going to be 1, and these graphs go forever up, up, up. They are going forever up into infinity. And then end behavior is going to be the same as what we've done before. End behavior on graphs like these are a lot easier, actually. You want to think about what end behavior is. End behavior means the limit as x approaches negative infinity of f of x is equal to, what that means, the limit as x approaches negative infinity, is what is happening on the left side of the graph. So all the way to the left side of this graph is right here, and it's literally saying, as the graph approaches negative infinity, what Y value are we hitting? And this Y value that we're not quite ever going to touch is 1. Remember, this line right here happens at Y equals 1. Alrighty, and then also, then we've got the limit, let me put this in red, the limit as x approaches positive infinity of f of x. So let's think about what that means. The limit as x approaches positive infinity is basically just saying what's going on the right side of the graph. So here's the right side of the graph, and what x value is it approaching but never touching, and that's going to be 1 again. So remember, one thing you should notice is that your range and your end behavior have everything to do with each other. You should be using similar numbers from your range and your end behavior. Number 4 is a little tricky. I am having you guys try that one by yourselves. And when you check your homework tomorrow, check and see how close you were, and we can answer questions on that when we get there tomorrow. But that is as hard as one of these problems gets. And so if you can see one of them, I think you could see them all. Don't forget to turn these in and show me a picture. If you already sent me a picture and you were incorrect about question 3, you do not need to send me it again, but I want to send this out to you so you understand where you went wrong when you check your answers tomorrow. Tomorrow is a part of tomorrow's lesson. I will send out the answers at the bottom. You just got to keep scrolling, and then the homework answers will be there. But if you have any questions on the homework or the notes or on this video per se, just let me know. You can message me on Remind or Teams or any of that matter. I miss you guys, and I hope you are all doing well and staying safe and staying fed.